Evening.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Okay, sir. Thank you. Good evening, everyone.
Good
Good
evening,
evening,
madam.
ma'am.
Good evening, ma'am.
Yes, good evening. Okay, so I think it's our last day of this FDP, right? And today the agenda is I'm going to discuss correlation and regression. My voice is okay, clear to everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Good evening, ma'am.
Yes, good evening, good evening. So, okay, so I think I'm starting with today's agenda, that is correlation and regression. So as per the tradition, I'm firstly discussing the conceptual aspect of both the tests, and then we'll see how we can perform them using the Excel, right? And later on, if time permits, we will discuss certain small caselets, and we'll see whether you are able to understand that which particular test is applicable in that particular scenario, right? Okay, Vijay sir, you want to ask me something? You have raised your hand.
No, ma'am, PPT is not visible. You are
I think I have not shared anything right now. I was just talking to you people.
okay, ma'am.
Yeah. So I will ask for confirmation once I'll share. Fine. So friends, now I'm sharing my screen. So I have shared my screen. Please tell me, is it visible or not?
Yes, ma'am.
Fine. Okay. So starting with firstly the concept of correlation. Okay. So correlation generally is the very important statistical tool, because for when we are going for the advanced statistical test, even in that case also at the initial level generally the correlation is calculated, right? And then we can perform further tests. So that is why there is a very important thing, or we can say the importance of correlation is very well known when we are talking about statistics, right? So for the purpose, you need to understand the concept of correlation. I think the meaning is only lying in the name itself of the test. So I think anyone can tell me, what do you mean by correlation? Anyone?
Ma'am, co means two, so correlation will tell us about the relationship between two variables.
Yes. Okay. So may I know who is speaking?
Ma'am, this is CS Nidhi.
Nidhi ma'am. Okay.
Yes, ma'am.
Thank you so much, Nidhi ma'am. So ma'am said co means not two, co means between, right? When we say correlation, so when we are interested to find the relationship between variables, we are using correlation, right? So correlation indicates the relationship between two variables, right? So that is a very simple definition of correlation. Relationship between two variables is generally studied using the or measured using the correlation concept, right? Now, when we go ahead and talk about correlation, exactly what tells us? So this tells us the strength of relationship, and strength meaning is degree, right? And the direction. Right? Strength meaning degree. Because we know we are getting the correlation value in the percent form, right? Generally, it is suppose it is 0.78, so we can say 78%, right? So that way, correlation can help you to understand the degree of relationship and the strength, and the direction of relationship, right? That means in which direction two variables are related to each other. That is the crux of correlation, right? Very simple, degree and direction. Then Generally, when we talk about correlation, we know this thing that firstly we need to know this thing, the variety, that is types of correlation. So under this, generally, simple correlation, right? Then multiple correlation, then partial correlation, then linear correlation, then non-linear correlation, then positive correlation, and negative. Right? So these are the types of correlation. Simple correlation meaning is when you are studying only relationship between the two variables. Right? When you are studying relationship between the two variables, it is known as simple correlation. Whereas multiple correlation is that when you are studying more than two variables for the relationship purpose, whether more than two variables are having some relationship among them or not, that is known as multiple correlation. Partial meaning is you are studying the correlation between a few variables by keeping other variables constant. Then linear correlation meaning is when the proportion of change is same. It is linear. That means when you are changing one variable by 1 unit, right? So other variables also change by the same proportion. It is linear correlation, right? Non-linear meaning is when the proportion of change is not same. You are changing one variable by 1 unit, other variable is changing by some other unit, maybe 2 unit, half unit, 1/4 unit, something like that. That is known as non-linear correlation. Positive correlation meaning is when two variables are moving in same direction. Meaning one variable you are increasing, other variable is also increasing. One variable you are decreasing, other variable is also decreasing. It is positive correlation. Negative correlation is when two variables are not moving in the same direction. That means if you are increasing one variable, other variable is decreasing. It is negative. For example, demand and price. If you are increasing price, generally demand gets decreased. That is negative correlation, right? Positive means suppose you are increasing the perks or the salaries of employment. So this may lead to the productivity increment, right? So that way you need to understand these are the various types of correlation available in statistics, right? Here we are only talking about the simple correlation, right? And then again, when I talk about this, I need to tell you one more thing. When you are talking about the correlation, you need to understand which type of variables you are having. So firstly, there are Karl-Pearson's coefficient of correlation. And the second one is known as Spearman's. Right. Then, apart from that, there is biserial correlation. Then there is Kendall-Stau. So these are other variety of correlation also available, right? So when to use which type of correlation, it is depending upon the type of variable you are having. So if you are having two numeric, that is spontaneous or interval or ratio scale variable, right? You are using Karl-Pearson's coefficient of correlation. When you are having two ordinal, scale variables. You are talking about square means rank correlation, right? For nominal, we are using generally Kendall's tau, right? So it is very imperative to understand which kind of data, which kind of variables you are having. According to the types, you are deciding that which will be the appropriate statistical test to perform on. Is it clear? I hope till here I am clear to everyone. Any doubts so far? Listening?
Madam, please explain linear and non-linear correlation.
Say, for example, I said if you are changing one variable by 1 unit, other variable will also changing by 1 unit. Direction is not, doesn't matter here. Only the proportion of change should be same. That is linear. Price, if you're increasing by 1 unit, demand is also increasing by 1 unit or decreasing by 1 unit. It is linear. But when the proportion is not same, you are changing one variable by suppose 1 unit. Other variables changing by suppose 0.5 unit, or maybe just double 2 unit, or maybe 0.25, whatever it is. So when the proportion of change is not same, that is known as non-linear correlation, right?
Yeah, thank you, madam.
Yes. Okay. So till here, I think I'm clear to everyone. Yes.
Yes, madam.
Yes. Now, talking about one more important thing, that is, when I talk about Carl-Pearson's coefficient of correlation, it is generally represented by small r. And I think everyone knows what is the value of r or what is the range of r. Anyone? Correlation can be minimum and maximum. What are the values of correlation?
-1 and 1.
One or less
-1, 0,
than
1.
one. One or less than one.
Yes. -1 to +1 is the value of r, right? But it is not necessary always you are getting 1 or -1, right? So according to the statistics, generally there are various interpretations of r, right? If suppose your r less than 0.5, or maybe starting with equal 1 or -1, plus minus 1, both you can take here, right? So it is perfect correlation, right? Perfect positive or perfect negative. When r is less than or maybe greater than 0.7, it is strong correlation, right? Again, strong positive, strong negative according to the symbol of the value, right? When r is less than 0.5, it is or maybe 0.7, less than 0.7, it is moderate correlation. And when r is less than 0.3, sorry, 0.5, it is low. Usually, if you will refer the statistical books, this range maybe means it is like so many breakouts is possible of the R value, right? So according to the books, maybe some other interpretation you can also get, but roughly if I talk about means if I talk about generally in statistics, mainly when, as I said, we are using correlation, right? So the important thing is you need to see generally 0.7 on above is the strong correlation, and less than that it is moderate, right? Generally books are referring less than 0.3 is low or weak correlation, right? Up to you, but usually according to the researches, generally we are keeping 0.5 and below it is generally known as the weak or low correlation, right? Again, I will repeat the same thing. I have not mentioned the symbols here. according to the symbols of the R value, you can write perfect positive, perfect negative, strong positive, strong negative, and likewise, right? So that you need to see, because this symbol will indicate you the direction of relationship, whether it is a positive relationship or it is a negative relationship, right? So symbol is very important here. Interpret plus or minus. That is the, I mean to say, sign is very important to interpret here, plus or minus, right? And then according to the value, according to the magnitude, you will comment on strong, moderate, or low. Is it clear?
Yes, ma'am.
Yes. Now, next term comes causation. Generally, people are what I can say, misunderstood the correlation. Some of people are understanding that correlation is nothing but it is causation. No, it is a wrong conception. It's misconception, I must say, right? Correlation is not a causation, because causation is something different. Causation here, in causation, we are talking about the cause and effect relationship, right? In causation, we are talking about this type of relationship. Whereas when you are talking about the correlation, there we are not talking about these two things. Because when you say cause and effect, that means you are talking about independent and dependent variable, right? So effect will be your dependent variable, cause will be your independent variable. Whereas in terms of correlation, there is no independent and dependent. Correlation treats both variable as variables only. It is not bifurcating among them, that is the independent variable or dependent variable. But being a researcher, this clarity we need to have, because further, if you want to go for the advanced statistics using correlation results, so you have to be clear in your mind which variable will behave like your dependent variable in your study and which variable will behave like dependent variable in your study. So independent dependent will be in the mind of researcher. That clarity should be with the researcher only, because software will not do this thing, as the softwares are generally designed, right? So they are understanding that these are the two variables, two series is available, and that software need to give the value of R, right? So being a researcher, you need to be very much clear in your thoughts that which variable you can take further as a dependent and which variable you can take as a independent variable. Correlation will not, what I can say, discriminate between the dependent and independent. It will treat the two variables as two variable only. Is it clear? I hope I'm clear. Friends, listening to me, I hope my voice is
Yes,
okay.
madam.
Fine.
Yes, madam.
Fine. So if it is clear, further, I will go ahead and talk about the next concept. So tell me, do I need to firstly discuss or complete the portion, then I need to take the regression, or I need to discuss both the concepts firstly and then one by one we need to apply them, as you say? Friends, what I need to do? Shall I go for the performance of correlation?
Yes, ma'am. Correlation and regression both. You can explain, then we can discuss.
Fine. Good. Okay. So if correlation is clear to everyone, as I discussed, we will move for the next concept, which is regression. Right. So regression is generally, we can say, a step ahead from the correlation. Although for the regression, we need to have the understanding about the correlation between the variables. If two variables are related, only then there is a possibility that one variable will affecting the other variable, right? Because regression is again measuring the relationship. But it will be algebraic. Relationship. Means here we will be having some magnitude of the relationship. Whereas in case of correlation, we have seen there is only the percent relationship between the two variables. It is not expressing them in the form of some numbers or something, right? But regression can help you to measure that relationship in the form of some numbers. That is why it is called algebraic relationship, right? Apart from that, regression can also be used for the forecasting purpose. Forecasting of PV using IV or maybe IVs, right? Apart from that, you can use the regression for modeling the variables, right? So these are the uses of regression. But for regression, correlation will be prerequisite. That means you need to have the idea about correlation between the two variables. If two variables are weakly correlated, it is quite possible that one variable will not impacting that much on your second variable, right? So that way you need to have idea about the correlation before performing the regression. So that is why all the softwares which are generally giving you the results of the regression, they are also giving the correlation value in the output of the regression, right? Fine, everyone? Is it clear?
Yes, madam.
Fine. Then talking about the types. Although there are various types, but here we are talking about linear regression, right? I must write here linear regression. So when we talk about linear regression, there are two types: simple linear and multiple linear, right? Simple linear meaning is when you are only studying two variables. One dV and one IV. And both will be numeric or continuous, right? Clear? This is simple linear regression. Fine, everyone?
Yes, madam.
Yes, ma'am.
Yes. Talking about multiple linear, here we are studying more than two variables. One dV, which will be numeric, and more than one IVs, which can be numeric or categorical, or means IVs can be in any combination. Maybe all numeric, maybe numeric, all categorical, maybe numeric and categorical, right? So that way, this is the requirement of multiple linear regression. I hope till here I am clear. Everyone, it is fine.
Yes, ma'am.
Fine. Then further, as I said here, in case of linear regression, I said modeling the variables. So to model the variables, generally in regression, we are formulating equation. That equation is nothing but that is a straight line equation. Anyone who can tell me the equation, a straight line equation? What is the equation? Yes. I hope you are listening to me. Anyone who can tell me the equation? I hope you are listening to me. Please say yes or no. Are you knowing or not? Any idea? Do you have anyone?
No, ma'am.
Fine. So when I talk about the suppose simple regression, the equation is y equals to a plus bx. And somewhere you can also find it as alpha plus beta x. Usually this is the linear line equation. And I think everyone has read this equation in the school time. Yes or no? We all have studied. Yes?
Yes, madam.
Yes, ma'am.
Yes.
Yes.
So here y is your dependent variable, right? A is your intercept. B is your slope or coefficient of x, and x is your independent variable, right? This is generally known as mathematical equation. But here, when we talk about regression under the statistics, so we are having one more thing here that is known as this, right? So that E is what? E is the error term or residual, right? Now, as I said, we are using regression for the purpose of forecasting, right? So when we are using regression for forecasting purpose, so it is quite obvious. Suppose I am having this equation here, right? And maybe I want to predict the marks of students, right? On the basis of their study hours. So I think example is very simple. We want to predict a student will score how many marks when he or she is studying for so many or whatever number of hours. This is the problem, right? I hope listening.
Yes,
everyone.
ma'am.
Okay. So if listening, this is the problem, right? Now, if suppose I'm having the old records of the students for the study hours and marks both, right? Using that, I will put a line. Means I will get a value of A and B, right? Because these A and B will help you out to get the value of marks, right? So suppose it is like suppose this is the equation. We got using the regression, we got the value of A and B or alpha and beta, and this is the equation. So here, for the prediction purpose, you can keep any of the value of this study hours of a student, suppose 8 hours, 7 hours, whatever it is, and that way you can solve it and you can predict the marks. So that will be predicted marks for you, right? So when you talk about E, that is error term. Error term is what? It is the difference of actual and predicted or forecasted value. Clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes. So this difference, if it is very large, that means your model is not a good model. Very obvious. If actual and predicted values are very far from each other, that means your model is not predicting properly. So that is the indication that your model is not a good model. Is it clear, everyone?
Yes, ma'am.
Fine. So that is why in statistics, when we talk about the assumptions of regression, so most of the assumptions of regression are roaming around this error term. Most of the assumptions are for the error term only or for the residuals only, right? Usually we can say the dependent variable and independent variable we will be having, both will be numeric. This is in case of simple linear regression, right? Apart from that, you will say that the residual will follow the normal distribution. So this is one of the assumptions of regression, right? You will say that the homogeneity of variances will be maintained by your residuals. This is the again one of the assumptions of regression. So most of the assumptions of regression are for the residual values, for the error terms. Is it clear?
Yes, ma'am.
Right. So I think this is the base of the regression which I want to explain you people. I hope it is clear.
Yes, ma'am.
Similarly, for the multiple linear regression, if I talk about, so in that case, what it will be A plus B1 x1 plus B2 x2 plus Bn xn plus, right? So it is depending how many independent variables are you are having. Accordingly, you can make the equation for the multiple linear regression as well. Is it clear? Friends, fine?
Yes, ma'am.
Yes, ma'am.
Fine. So now, friends, if the base is clear, the concept of the regression and correlation is clear, now we will move for performing the correlation, right? So first thing is you need to perform firstly the correlation. So the sheet I already shared on a WhatsApp group. I hope you people have downloaded it. Now open the first sheet named as correlation. Are you people ready with the sheet? Shall I proceed?
Yes, ma'am.
Fine. So if you are ready, you can see we are having two variables listed, temperature in Celsius and sales of ice cream. So which type of variable these are? Yes,
Numeric. Both are numeric variables.
both are numerical. Thank you so much. I think Gautam sir it was. Thank
Yes,
you so much, sir. So both the variables are numeric in nature here, right? We will go for performing the correlation. So there are two ways of performing correlation. First one is using the function. Second one is using the data analysis tool pack, right? So firstly, if suppose I want to formulate my hypothesis, I will write there is right. Clear, everyone? Null and
Yes,
odd.
ma'am.
Yes. There is no significant relationship between the temperature and the sales of ice cream.
Yes, ma'am.
Yes. Firstly, we will use here the function to perform correlation. So suppose I am typing equal, then you can write COR, and you can find there is only one function which is starting from COR, which is the CORREL, correl, right? This is asking you to provide the arrays. That means you can provide the series or the range of your data. So I selected the first column, comma, and then I select the second column. That's all. And close the bracket. Done, everyone? Done?
Yes, ma'am.
Okay. Yes, ma'am.
Okay, so I entered, and I think same value you people are also getting. It is 0.75339. That is a strong positive correlation between the two variables. That is temperature and sales of ice cream, right?
Yes, ma'am. Correct.
So this is the first way. Second way is you can go to the data tab and using the analysis tool pack, you can select the correlation. I hope everyone is able to locate correlation in a dialog box.
Yes, madam.
Yes, ma'am.
Now click on OK. This is asking you the input range. So I'm selecting the range, including the labels, including the headings of my data. So my range is B:(C11). B1 colon C11 is my range, right? Now, column data is in the columns only, so we will go with the by default option. Labels are selected, so I checked it. I want to generate the output in the same sheet, right? So I select the blank cell. I hope it is okay.
Yes, ma'am.
Yes, ma'am.
Yes, now click on OK. Done? Got it?
Yes.
Fine. Now you can look at the table. This will be the same value which we are getting, but in the tabular form. That means in the same variable, temperature and temperature, it is quite obvious the relationship will be 1. Sales and sales relationship will be 1. But between temperature and the sales, the correlation value is 0.75 with the 9, which is again I can say it's the same value which we have got using the function. That means the strong positive correlation between the sales and the temperature of the ice cream, or sorry, temperature of the environment. Done. Done, everyone?
Yes, ma'am.
Okay,
Yes,
ma'am.
ma'am.
But
Okay, ma'am.
yes, but if you have observed, when we got the table also using the data analysis toolpad, it is not providing us the p-value, right? So to accept or reject the null hypothesis, you need to have the p-value, which is not available. So for the purpose, there is a function I have used for ascertaining whether you are accepting or rejecting the null hypothesis of the correlation. You will use the t-test here. So this t-test is in the form of correlation. You can see t equals to r under root of n minus 2 divided by under root of 1 minus r square, right? So firstly on this, I think we have seen the one sample t-test. In that case also I told you, you can use Excel as a calculator only. Here also we will use the Excel for the as a calculator only, and we will get the t value, and then using this we will get the p value. Is it clear?
Okay, ma'am.
Fine.
Yes, ma'am.
So come here. Here you can see I will firstly calculate the n. N is what? It's a count, right? So you can select any of the series because it will always be in pair. So the count is coming as 10, right? Done, everyone?
Yes, ma'am.
Then R is known to us. R is what? Sorry. This is your R value, right? So we are having N and R. Both the values are available with us. Now we need to perform this. So suppose I'm firstly calculating the numerator. What numerator says? It is R, this, into square root of this minus 2. Done? Done, everyone?
Ma'am, doing.
Okay.
Yes, ma'am.
Done. So the numerator is 2.1309, not denominator. Which is square root of 1 minus r square, means r into r. Done?
Yes, ma'am.
We got the denominator. Now the t value, which is the ratio of numerator and denominator. Done?
Yes, ma'am.
I hope everyone has got the same figure, 3.24.
Yes, ma'am.
Yes, ma'am.
Now we will calculate the p-value. Then provide the this and degrees of freedom will be this minus 1. Done.
Yes.
So we are getting the p-value 0.005075,
07
which is less than
1.
0.05, right? Yes or no?
Yes, ma'am.
So that
Yes,
means
ma'am.
we can comment that the correlation is significant between the temperature and the sales of ice. I hope it is clear.
Yes, ma'am.
Yes, ma'am. Yes.
Done. If it is clear, next sheet you can use for your practice purpose, which is this one, right? And then I'll move for the next test, which is regression. So shall I?
Yes, ma'am.
Fine. Open the regression sheet now. Concept we have already understood here. And the example is saying we are having COVID cases and mass sold data for the 12 months, right? Done, everyone?
Yes, ma'am.
Now, anyone who can tell me which variable you can take as a dependent and which variable you can take as an independent.
COVID cases is
COVID cases,
independent
yes. Yeah.
and
Yeah.
mass sold will be dependent.
Its mass
Yes.
hold is dependent.
Very good. Now we will formulate a hypothesis. Done? There is a significant impact of COVID cases on mass sold or sales of mass, right? Done, everyone?
Yes.
Now, after getting the clarity, we will go to the data tab. We'll go to the data analysis toolpath. And going down, we need to select regression. I hope everyone has located this.
Yes, ma'am.
Click on OK. It is
Yes,
asking
ma'am.
clearly. Yes, it is asking clearly your input Y range and your input X range. So Y is the dependent variable, X is the independent variable, right? I think just a minute. We have We have read wrongly. COVID cases will be independent, no? This is what you said. Yes or no?
Yes, ma'am.
Yes, I have written it wrongly. Yes.
Yes, ma'am. Yes.
Now, input Y is your dependent variable, that means mass sold. So I will select the column number 2, mass sold, right? Then input is number of COVID cases. So that way I selected the 2 ranges for 2 variables, dependent and independent, including the labels. right? And everyone,
Yes, ma'am.
Yes, ma'am.
now select the checkbox labels. Done. Constant is 0. So the constant, that is A, we don't want to make it 0. So don't select this. Confidence level is 95% by default. It will give you the results at 95% confidence level. Output I want to generate here only. And then going down. If you will perform this only, what we did, and click on OK, even then you can get the output of the regression, right? Now, if you want to test the assumptions, you can select these three check boxes: residuals, residual plot, and line fit plots. Done. Done, everyone. Everyone okay?
Yes, ma'am.
Then if you want to see normal probability plot also, you can select this also and then click on OK. Got it, everyone? Everyone? Receive the output.
Yes, ma'am.
Shall I start interpreting it?
Yes,
Okay,
ma'am.
ma'am. Okay.
Yes. So the first table is the regression statistics table. First value is coming as the R value, that is multiple R means. Generally, it is a name given in the software, but it is a correlation value, right? So it is 0.98, which is what I can say very close to the 1, right? That means it is indicating there is a strong positive correlation between the COVID cases and masks sold. Is it clear?
Yes, ma'am.
Now, next you can find there are two terms, R square and adjusted R square. So in case of simple linear regression, you need to report R square. In case of multiple linear square
It
regression,
is SLR, simple linear.
we will use R square. Multiple linear regression, we are using adjusted R square. So here we were talking about the simple linear regression, as we are having only two variables. So we will only interpret R square. Interpretation will same. There is no change in the interpretation. Only you need to understand when you need to report which, right? So we are using R square here, which is 0.96. So the meaning is that is 96% of DB, which is mask sold or sales of mask, is 96% of variance, I think is the correct word, variance. (96% of the variance in DV, that is mask sold, is explained by IB, that is COVID cases. Right? Clear, everyone? Means how much percent variance is in your DV is explained by your independent variable that you can understand using the R square. That means how much change your independent variable is making in your dependent variable. In the simple words, if you want to understand. So how much % change your independent variable is making in your dependent variable, that you can study using the R square. Clear?
Yes, ma'am.
Fine. Then adjusted R square, you do not need to report. Standard error is 141.848, and in observations we are having total 12. Next comes the ANOVA table. ANOVA table is again one of the very important table in case of regression, because this table can tell you whether your model is a good fit or not. So you look at the F significant value, which is 2.43 E minus 0.8, which is very small, less than 0.05. You can call it your model is significant or good fit. Clear? Clear, everyone?
Yeah, this
Yes, ma'am.
significance, no, ma'am, the significance level,
Sorry?
the significance level, it means basically, I mean, the less value means better fit.
Sorry?
I mean, the significance level,
Hmm.
which is point very less here. A less value of significance level meaning greater fit. I mean, meaning
Hmm.
good fit.
Hmm.
Yeah, yeah. So it's actually that alpha. Is it
This is
actually
not
that
alpha. You are comparing it with alpha.
Acha.
Always we are comparing significant value by alpha value only. That is
Yeah,
the
yeah.
level of significance.
Yeah,
So
yeah,
outside this thing, it is less than 0.05.
yeah.
So that
Okay.
means your model is significant. Whatever model you will make using
Yeah.
this output, that will be significant, or it will be a
Right.
good fit between your variables.
Yeah. Okay, madam. Okay.
Fine. Going down, talking about the important table, that is coefficient table. You can find here. Here we are having the intercept value and the coefficient value of the COVID cases. That is A and B value, or alpha and beta. This is your A or alpha. This is B or beta value, right? So when you talk about these two values, you cannot comment anything whether these are significant or not. So how you can ascertain these two values are significant? So for the purpose, we are having one more thing available in the table, which is t statistic and the p value, right? So according to the p value of the t-test, you will ascertain whether these two values are significant or not. So you can see both the p values are less than 0.05. That means you can say that the intercept and the coefficient of the COVID cases both are significant or maybe significantly contributing to your dependent variable, right? That means these are different from the zero. These are not zero. These are significant from the zero. That is why you can make a good equation using these. Is it clear? Yes, friends. I hope you are listening to me. It is clear, friends? What I said, it is clear or not?
Yes, ma'am.
Fine. If it is clear, we have decided these two are the significant value. We can make our equation, that is y equals to A plus B x, or mask sold equals to minus 245.631 plus 0.994556 into COVID cases, right? That means per unit change in the COVID cases, there will be 0.99 unit change in the mass sold when you are keeping your intercept constant, right? Is it clear? If COVID cases will change by 1 unit,
Yeah. Okay,
right?
ma'am.
So mass sold will be changed by 0.99 units when you are keeping your A value, intercept value constant, right?
Yes, ma'am.
So if you are having suppose 1000 cases, so you can keep here 1000 will be multiplied by 0.999, right? And that way it will give you one figure. You will subtract 245.631 from that, and you can say this will be the sales of mask for a particular month, right?
Yes, ma'am.
I hope clear to everyone.
Yes, ma'am.
Fine. Apart from that, you can see we are getting some more results here. This is the predicted value, and this is the residuals value, right? Getting my point? So predicted value meaning is once we are coming here, this is your equation, right? So for the January month, COVID cases were 40, right? So you can keep here 40. Multiply this by this and subtract this. This will give you the mass sold value for the first month. Getting me? Friends?
Yes, ma'am.
I want to show you this, just a minute. A is getting how I calculated this, and then residual, actual minus predicted. Getting my point? Friends?
Yes, ma'am.
Done? So this way you can calculate predicted values by your own. You can find this is the residual we are getting, same residual we are getting here also, right? Done? So you can compare your figures. We are getting similar figures which were generated by Excel for us, right? Then we are getting certain charts also. This is indicating whether your residuals are normally distributed or not. So if you can see, you can find if you will fit a line here, right? So the residuals value will almost, what I can say, on the line. That means your residuals are normally distributed. Is it clear? Friends, this is the COVID cases line fit plot. You can see blue color is for the mass sold and this orange color is for the predicted mass sold. So that way you can find coincidence, means the blue and orange color are almost parallelly going or simultaneously going, right? Going hands on hand. there is no or there is very less deviation in the predicted value and in the forecasted value. That is, sorry, actual value and the forecasted value. So somewhere you can say this is prediction is good. Yes or no?
Yes, yes, ma'am.
Yes. Then here, homogeneity of variances. Although we are having very less data here, only 12 observations we are having. So when we are having sufficient large data set, this graph will be better interpretable in that case. Right now we are having only 12 observations. So that is why we are having very less data on this particular graph. How you can interpret? You can see the middle line is the zero line, right? So distribution should be almost equal at both the side, upper side and the lower side of the zero, right? And there should be no particular shape you can find. That way you can say homogeneity of variances is met by your residuals. Clear? Equal distribution of these data points against this particular zero line. Both sides should be equal distribution, right? Is it clear? Is it clear, everyone? I hope you are listening to me. Yes or no?
Yes, ma'am.
Fine.
Yeah.
This way, these are the assumptions which we can check using the graphs, right? One thing I forgot to tell you, that is in case of correlation. If you wish to see correlation graphically, that is also possible. How? For that, you can go to the Insert tab. Firstly, select your data, right? Go to the Insert tab or menu, and that way in the chart section, you can find there is a chart section. In that third line, second option is the scatter plot. Click on this and select the first one. It is indicating or giving you the scatter plot. Yes or no? Visible?
Yes, ma'am.
Yes. This is your scatter plot. Now you can click on this plus sign and click on the trend line. So this is fitting a trend line between your data points, right? Then clicking on the further extended arrow, you can click on the more options. And then from here, you can click on the display equation on chart and display R squared. That way also you can show the regression equation here. Clear?
Yes, ma'am. Very easy. Good.
And you can comment here. If you can see the line which is fitted is the straight line, although, and it is upward type, means there is a positive correlation. We have already seen this thing, right? So it is indicating there is a positive correlation and a strong positive because it is going in an upward direction, right?
Yes, ma'am.
Clear to everyone? Friends, why
Yes,
people are
ma'am.
so quiet today? Okay. Now, if it is clear, next sheet you can use for your practice purpose. I will only tell you now how to apply multiple linear regression using the SPS, using the Excel, right? So for that, go to the MLR. Everyone has opened the next sheet. Opened, everyone? Why people are so quiet today? Are you not interested in studying today? Or something which is not clear to you people? Please tell. Otherwise, it is difficult for me to understand. Till yesterday, people were interacting. What happened today suddenly? Yes.
No, ma'am, there is nothing like that.
So shall I proceed? At least say yes or no, because I'm
Yes,
asking
ma'am.
some
Proceed.
questions.
Yes,
Yes.
ma'am,
Proceed, please.
definitely.
Yes, ma'am.
Fine, fine. Thank you. You
Mm.
can find, find here that we are having three columns, y, x1 and x2. So y is your dependent variable, x1 and x2 are your independent variable. So we are having more than one independent variable. That means this is a case of multiple linear regression, right? For that, you will go again, data type, data analysis toolpath, and again regression you need to select, right? Previous ranges you can remove, right? So I'll come to the first y and I'll select the range of y. Then coming to the next, selecting the range of x. So both the x you will select simultaneously, both the columns, and rest will be same. I am removing all these right now. And this also you can change, right? Done?
Yes.
And click on OK. Fine. You can find we are getting the regression results. Multiple R will indicate you the portion between your variables. R square we will not interpret, we will interpret adjusted R square. So it is indicating 61.4% variance or change in your dependent variable y is explained by both of the individual variables simultaneously. Means both the variables simultaneously make change around 61.4% change they are making in your dependent variable. Is it clear?
Okay, madam.
Fine. Total observations were 10. ANOVA table you can look at, which is significant value is 0.01, which is less than 0.05. So you will comment that model is a good model or a model is a significant model, right? Then coming to the next, you can find here these three values we are getting. And all these three values are significant because all the p-values are less than 0.05. So your equation will be y equals 43.1092 minus 0.81815 multiplied by x1. This is the coefficient of x1, right? Plus 2.41772 multiplied by x2. This will be your equation. Done, everyone? Everyone is
madam.
fine?
Yes, madam.
Yes, madam.
Fine. So I think now I will summarize the session and then we will take certain case lists which can help you to understand. So it's according to the situation, according to the type of variable, which test you can perform on, right? So friends, today I discussed correlation and regression, two concepts, right? In correlation, we have seen it is telling you the strength, that is degree of relationship, and also it is telling you the direction of the relationship. These two things are, or these two things we can explain using the value of R. So R is coefficient of correlation, which ranges from -1 to +1. -1 or +1 is always a perfect correlation, negative and positive according to the symbol. 0.7 and above, it's a strong positive. With less than 0.7, it is moderate. Less than 0.5, it is weak or low correlation, right? We have seen various types of correlation available in the statistics. Today, we have talked about only the simple linear correlation, where we have considered two variables. Then we have seen the drawback of Excel is that Excel is not providing you the p-value to comment whether the correlation is significant or not. So we have taken the help of t-test there, and using that we have understood this thing, that how we can say whether the correlation between the variables is significant or not. This is what we have done in case of correlation today. In case of regression, we have understood that regression is a step ahead from the correlation. Correlation only indicate you the relationship in the form of percentage, whereas regression can help you to give the relationship between the variables in the magnitude form, in the what I can say in the algebraic form, right? So you can express the relationship in the algebraic form in case of regression. Regression can help you in the forecasting of your dependent variable using your independent variable or variables. And also you can go for the modeling here using the regression, right? Then we have seen the types, as we are only discussing the linear regression. So I told there are two types, simple linear regression and the multiple linear regression. Simple linear regression is only needs two numeric variable, whereas multiple linear regression is requiring the one dependent variable numeric, and there can be any number of independent variables, right? They can be numeric, all maybe categorical or maybe combination of numeric. Then we have seen regression using the Excel, and in the interpretation, the important thing is that you need to report R value, R square value, and then F and significant value to comment that model is a significant model or not. And lastly, the coefficient value along with the P and the P value. These you need to report in your research papers if you are performing a regression in your research paper. And that way you can make your equation like this in case of simple and multiple linear regression. So this was the theoretical and the practical background of the regression from my side. So I think I can go for now caselets. If you are having any queries in between you want to ask me, you can ask. Or do I need to go directly for the caselets? You need to tell me. So please tell me what I need to do first. Taking your queries first, I need to go for the caselets discussion. Friends, what happened today? Why you people are not talking? It's the last day. That is why.
No, ma'am, nothing like that.
So please tell me what I need to do first. We will go for firstly discussing the caselets, and afterwards I will take your problems or any questions as you people say. Okay, fine. So I think I'm starting with the caselets, these studies. So I'm expecting you to spare a few seconds on reading the case, reading the caselet, try to understand, and then tell me which test will be applicable here. Anyone? Which test is applicable here? I hope people are reading it. I think my energy is little down today. So is it like your energy will also be down? Is it something? Friends, say something. I'm not getting you people today.
Can this be a case of ANOVA?
ANOVA, according to the Gautam said ANOVA, fine. Anyone else? Just a minute. I will share it again. I will share only a window so that I can see you people also. Yes. Okay, Gautam sir is saying ANOVA. Anyone else? Yes. Anyone, please. Are you understanding the situation or not? Take a lead.
Ma'am,
Yes, Visudha ma'am.
correlation.
Correlation. Fine. Any other answer? Any other opinion? One is ANOVA, one is correlation. Any other opinion?
Ma'am, is it regression?
Regression. Okay, one more opinion, regression. Any other opinion? Or maybe same opinion, you can say. Fine. I think you people are maybe only reading and waiting to get an answer. Fine. According to me, this is a chi-square test. Reason is, you can see, we want to find here the association between the variables, right? And the variables which are given here are the categorical in nature. Class label, freshman, sophomore, junior, senior, and the movie genre, thriller, drama, and western. So in that case, I think it is possible we will be having only the count available. How many of the freshmen are watching thriller type of movie, drama, or western, likewise. So that way, when the count is there, an association we need to find. So these two categorical variables are given. So we will go for here the chi-square test. That is test of association. Getting it?
Yes, ma'am.
Yes, ma'am.
Fine.
Yes,
Next,
ma'am.
yeah. Next is this.
Ma'am, it seems to be a t-test.
T-test. Okay, fine. Okay. Any other opinion? Okay, someone has written, I think Harmanpreet for ma'am has written it's ANOVA. Okay, fine. Okay. Any other opinion? Correlation, Vasudha ma'am. Fine. Two-way ANOVA. Chintan sir said two-tail ANOVA. Two-tail, it's two-way. It's two-way. It can be two-way. Means two-tail no. Okay. Manpreet ma'am again is saying it's two-way. Okay, fine. Answer changed now. Okay, fine. Okay, I think many of you are writing in a chat. It's difficult for me to read everything, but okay, fine. So according to me, it is a case of two-way ANOVA because you can find we are having two categorical variable, temperature and the type of sugar, and in the combination of these two, we will be having the weight of the cookies, right? That is numeric variable. So two categorical, one numeric. We want to see the impact of these categorical variable on your dependent variable or on your numeric variable. So this is a case of two-way ANOVA. So those who have identified it correctly, it's well done. Good. I'll take one more. Yes.
It's t-test.
T-test. Okay. Prachi ma'am, which t-test? Okay. Anyone else? Yes.
Pair t-test.
Tanu ma'am is saying paired t-test. Okay. Any other opinion? Okay, whosoever is writing t-test, please specify which t-test. That is important. Which t-test you are going to apply here? Anyone? Any other answer? Yes. One tail t-test.
One
That
tail.
it's one tail.
Yes, ma'am. One tail t-test.
It is one sample. It's not one tail. It is one sample t-test.
Yes, ma'am.
Answer is correct. It's one sample t-test. Okay. Why so? Because here your claim is what I can say, testing a claim of a particular bakery, right? No, bakery, no, of a particular company, right? So you need to have means companies, what companies claiming that their batteries are generally, life of the battery is generally 40 hours. So to check it, to check its claim, maybe the quality inspector has taken sample of 15 batteries. Getting? And that way mean life can be checked of those batteries from the claimed value, hypothesized values. This is a case of one sample t-test. Is it clear, everyone?
Yes, ma'am.
Fine. Now next. Now next.
It's ANOVA.
ANOVA.
Two-way ANOVA.
ANOVA. Okay. Okay. Any other opinion? Very correct. I think many of you are seeing it as a yes. Yes, ma'am. Yes, ma'am.
Ma'am, is it not paired t-test?
How it will be a pair t-test?
Because there are two given, before and after, so I thought it is paired t-test.
No, I think it is written she plants 40 seeds and let them grow. It is not mentioned 2 times the measurement has been taken of the height of the plants.
Right, ma'am. Thank you.
Yes, yes. So one last problem I will take for the day. Just a minute.
I think it is ANOVA.
Okay. Okay. Okay, Prachiman. What about others?
Pair t-test.
Pair t-test. Who said? Who said pair t-test?
Ma'am, it's me, Tanu Tyagi.
Tanu, ma'am. Okay.
Yes, ma'am. It seems to be a pair t-test.
Okay. Okay. May I
Ma'am,
know?
one-way ANOVA.
Sorry?
One-way ANOVA.
Vasudha ma'am said one-way ANOVA. Okay. Those who are saying it is a case of pair t-test, can you justify why it will be a case of pair t-test? Read it very carefully. Vasudha ma'am said correctly, it is a case of one-way ANOVA. we are having the patients. To some of them, we can give the medication. To some of them, we can ask to go for the exercises. Some of them can be asked to go for the special diet plan, right? And that way, their blood pressure on a particular days we can note down, and that way you can get the mean of a different groups, and you can compare that. So it is possible using the ANOVA only. One way. Is it clear?
Yes, ma'am. Okay.
Yes, ma'am. Yes. So friends, I think this is all from my side. Now session is open for questions and answers. If you are having any question, you please ask me. And that way at the end, I will request you. At the end, I will request you all to please switch on your cameras so that I can capture you all. Clear, everyone? I hope you people are listening to me. Any question you have, please ask. Okay. Directly people have switched on your cameras. That means people are not having any query. Is it something?
All the things were very nice. You understood very nice.
So the course was very nice and it was really taken up gradually. We moved into the little complicated topics. And as I said, we need to practice a lot. Maybe after that, we'll be able to really solve any problem and more expertise can be gained. Thank you, madam, for all
Thank you
your
so much,
efforts.
sir, for the
Thank-
interaction you held during all the 5 days. Thank you so much.
Thank you. Thank you, ma'am.
Thank you, sir. I think Ajay sir is also there. Ajay sir, I think I have seen you.
Yes, ma'am. Thank you so much for all wonderful sessions.
Thank you, sir.
Ma'am, when will be getting certificate?
Certificate will be delivered within 3 working days in your mail ID.
Sir, okay, sir, no problem.
Good evening, ma'am.
Yes, good evening, ma'am.
Ma'am, I am still facing one problem.
Yes.
In the afternoon, I was looking for the link you said, no, in that it's available on YouTube, the sessions. So I wanted to revise something. I did not get the link. So can you please share the link whenever time permits? Like there are days when we want to just revise whatever we have learned.
Radhika ma'am, when have you joined the WhatsApp group?
Ma'am, I had joined quite late.
Okay. So yesterday you was there in a
Ma'am,
meeting.
ma'am, already shared in the chat box. Please check.
One
I'll
more
just
time, Ajay
check
sir.
and I'll check right away and I'll let you know, ma'am. Because I had texted you also today in the afternoon while I was revising that, ma'am, I'm unable to find the link.
Then you
But
can check the chat box of this meeting. There, sir has pasted
Ma'am,
all
please
the
can
lines.
you share it in the WhatsApp group because chat box will go off once we switch off this.
yes, this is the
meeting.
problem that
No,
we
no,
face,
you
ma'am.
can copy and paste in your Word file, no, ma'am. This is what we are saying. Or maybe you can copy in your chat box also, in your WhatsApp also, no problem. But I think we can request Yogi sir. Yogi sir will also share on your WhatsApp groups.
Thank
Ma'am,
you so
one
much.
request for me from my
Thank you.
side.
Sorry?
Actually, I was unable to join the WhatsApp group. Okay. So right now, I am checking that link was disappear. The link is not working. WhatsApp group link.
Okay.
Sir, I think all the links for all the 5 days, it's shared on the mail as well.
And Santosh sir, I think again the WhatsApp link has been shared there in our chat box. You please check. You can click on this, and that way you can join the WhatsApp group. But for that, you need to attend or join the meeting through your mobile. If not, you can copy somewhere, and that way you can take it on your WhatsApp, and you can join this group. No problem.
Okay, ma'am.
One thing I can help. See the invitation mail that we received from RFI. There, all the days YouTube links are also given. So
Yes.
if you just open your email, you get all those links.
Okay, ma'am. So now we can conclude the session, ma'am.
Yes, sir, we are done.
Asmi ma'am, are you there?
Yes, sir.
Ma'am, please conclude the session.
Sure, sir. Thank you so much, ma'am, for all the wonderful sessions. They were really knowledgeable, enriching, and engaging. Also, they were very informative, ma'am. I also express my gratitude to all the participants as well for the active participation. Thank you so much, everyone. Thank you so much, ma'am.
Thank you so much, Ashmi ma'am, and thank you all the participants for attending this 5 days FDP. I think patiently you have listened to me all 5 days, interacted with me. So thank you so much for that. I wish you all the very best for your research journey. Thank you.
Thank you, ma'am.
madam.
Thank you so much, ma'am.
Thank
It
you,
was
ma'am.
great session.
Thank you.
Yes.
Thank you.
Thank you for teaching us with so much patience, ma'am.
Thank you, Radhika ma'am.